Good day everyone, my name is Patrick A. Destajo and let's discuss maturity indices. So what is maturity indices? This is the principles governing when a fruit or vegetable should be harvested are critical to its subsequent storage, marketable life, and quality. Post-harvest physiologists divide the life cycle of fruits and vegetables into three stages, which is maturation, ripening, and senescence. Maturation indicates that the fruit is ready for harvest. The edible part of the fruit or vegetable is fully developed at this point, but it may not be ready for immediate consumption. Ripening indicated by taste. Senescence is the final stage and it is characterized by natural degradation of the fruit or vegetable, such as loss of texture, flavor, and so on. So, what is the importance of maturity indices? In terms of harvesting fruits, vegetables, and flowers, it is very important to understand the maturity indices of crops in order to fully determine when it is appropriate to harvest. It also helps to prevent the entropy of fruit crops. For example, overripe fruits are sometimes wasted because they are prone to damage. Speaking of damage, it will also help to prevent damage to fruit crops due to improper harvesting techniques related to post-harvest handling studies. Now, let's move on to the following maturity indices. First is skin color. This factor is commonly applied to fruits. Since skin color changes as a fruit ripens, matures, some fruits exhibit no perceptible color change during maturation, depending on the type of fruit or vegetable. Assessment of harvest maturity by skin color depends on the judgment of the harvester. But color charts are available for cultivars such as apples, tomatoes, peaches, chili, peppers, and etc. Next is optical methods. Light transmission properties can be used to measure the degree of maturity of fruits. These methods are based on the chlorophyll content of the fruit, which is reduced by maturation or during maturation. The fruit is exposed to a bright light, which is then switched off so that the fruit is in a total darkness. Next, a sensor measures the amount of light emitted from the fruit, which is proportional to its chlorophyll content and thus its maturity. Juice content. The juice content of many fruits increases as the fruit matures on the tree. To measure the juice content of a fruit, a representative sample of fruit is taken and then the juice extracted in the standard and specified manner. The juice volume is related to the original mass of juice, which is proportional to its maturity. Next is starch content. Measurement of starch content is a reliable technique used to determine the maturity in pear cultivars. The method involves cutting the fruit in two and dipping the cut pieces into a solution containing 4% potassium iodide and 1% iodine. The cut surface stained to a blue-black color in place where starch is present. Starch converts into sugar as harvest time approaches. Harvest begins when the samples show that 65 to 70% of the cut surface have turned blue-black. Leaf changes. Leaf quality often determines when fruits and vegetables should be harvested. In root crops, the condition of the leaves can likewise indicate the condition of the crop below the ground. For example, if potatoes are to be stored, then the optimum harvest time is soon after the leaves and stems have died. If harvested earlier, the skins will be less resistant to harvesting and handling damage and more prone to storage diseases. Abscission. As part of the natural development of a fruit, an abscission layer is formed in the pedicel. For example, in cantaloupe melons, harvesting before the abscission layer is fully developed results in inferior flavored fruit compared to those left on the vine for the full period. Shape. The shape of fruit can change during maturation and can be used as a characteristic to determine the harvest maturity. For instance, a banana becomes more rounded in cross sections and less angular as it develops on the plant. Another example is the mangoes that can also change shape during maturation. Size. Changes in the size of a crop while growing are frequently used to determine the time of harvest. For example, in bananas, the width of individual fingers can be used to determine harvest quality or maturity. Usually, a finger is placed midway along the bunch and its maximum width is measured with calipers. This is referred to as the caliper grade. Next is aroma. Most fruits synthesize volatile chemicals as they ripen. Such chemicals give fruit its characteristic odor and can be used to determine whether it is ripe or not. These odors may only be detectable by humans when a fruit is completely ripe and therefore has limited use in commercial situations. Fruit opening. Some fruits may develop toxic compounds during ripening, such as ackee tree fruit, which contains toxic levels of hypoglycemia. The fruit splits when it is fully mature, revealing black seeds on yellow areoles. At this stage, it has been shown to contain minimal amounts of hypoglycemia or none at all. Firmness. A fruit may change in texture during maturation, especially during ripening when it may become rapidly softer. Excessive loss or moisture may also affect the texture of crops. These textural changes are detected by touch, and the harvester may simply be able to gently squeeze the fruit and judge whether the crop can be harvested. Next is oil content and dry matter percentage. Oil content can be used to determine the maturity of fruits, such as avocados. According to the Agricultural Code in California, avocados at the time of harvest and at any time thereafter shall not contain in weight less than 8% oil per avocado, excluding skin and seed. Thus, the oil content of an avocado is related to moisture content. The oil content is determined by weighing 5 to 10 grams of avocado pulp and then extracting the oil with a solvent in a distillation column. This method has been successful for cultivars naturally high on oil content. Sugar. In climacteric fruits, carbohydrates accumulate during maturation in the form of starch. As the fruit ripens, starch is broken down into sugar. In non-climacteric fruits, sugar tends to accumulate during maturation. A quick method to measure the amount of sugar present in fruits is with a Brix hydrometer or refractometer. Acidity. In many fruits, the acidity changes during maturation and ripening. And in the case of citrus and other fruits, acidity reduces progressively as the fruit matures on the tree. Taking samples of such fruits and extracting the juice of titrating it against a standard alkaline solution gives a measure that can be related to optimum times of harvest.